Hey guys, tight quarters today because we got a ton that's going on right now. We've got to do this entire titration, we've got to heat it up, and we got to add a lot of different things, including our oxalic acid. So today's lab is titrating oxalic acid with a potassium permanganate standard. Now, this potassium permanganate standard was made according to the recipe inside of your lab handout. So we're going to assume that we need about 20 milliliters of that potassium permanganate to titrate whatever we want to weigh out. Well, if you look at the molarity that you're supposed to make and then you do the calculations for how much oxalic acid we should use, we should get somewhere between 0.06 and 0.07 grams of oxalic acid. So let's go weigh that out right now. Okay, just a little bit too much. And that seems perfect. So we are going to do this titration today with 0.0645 grams of oxalic acid. 0.0645 grams. All right. I'm going to put that inside of here, and then we are going to add a little bit of distilled water to here. Let me go grab that. All right. They say we need to use 50, but since the only amounts that we really care about are the mass of the oxalic acid and the amount of potassium permanganate we use, everything else is added bonus. Everything else just allows the reaction to happen. So inside of the lab procedure, it says you have to add some sulfuric acid and you have to add some potassium permanganate. Those are to get the H+ ion in there. So remember, when we're balancing redox reactions, sometimes we need to add H, sometimes we need to add H2O, and sometimes we need our H+, H2O, or OH-. So today we need to add H+ onto the reactant side to make sure that there's enough H ions to allow for this process to happen. Okay, we have got our 50 mils. And now I'm going to start our stir bar going to make sure that this is thoroughly dissolved. Okay. So now the next step is we need to add 6 to 7 milliliters of sulfuric acid. So I'm going to grab that from over here. This is 6 molar sulfuric acid. Okay, we got 5 mils. And there we go, 6 mils. I'm going to add that to our substance. And then we need 1 mil of 85% phosphoric acid, which is right here. Okay, there we go. All right, I'm going to add a little bit of water to here to make sure I got all of that phosphoric acid in there. because water does not matter to this. I'm going to also do the same thing, and I'm going to rinse out my other graduated cylinder. Okay. It's probably maybe an extra 2-3 mils total. All right. So now what we need to do is we need to check temperatures, and we need to make sure that this gets above 60 degrees, somewhere in the 70 to 80 degree range. So I'm going to take a quick temperature of it right now, and it is 23.1 degrees. I'm going to turn it on 6 and let that cook a little bit while we rinse out this burette and get it ready to actually run the titration. To rinse the burette, what we need to do is add 2 5 milliliter aliquots of our potassium permanganate standard. So that way we can make sure that this entire burette is cleaned, rinsed, and coated with the proper molarity of potassium permanganate. Okay. So I'm going to add, this is about 6. All right. See that it's already starting to coat this with purple. That's good. I'm going to drain it all the way down. Right to there is about good. Okay, we're going to add another one. It's about 5 mils. Okay. Check the temperature really quick. We're at 32. All right. Okay. And now we're going to fill this sucker up all the way. Since we've got some time to kill, we're going to do it safely by just adding a little bit of this KMnO4 at a time. All right. We're going to start today our titration at about 5 milliliters because I want the end range to be in the right view of the GoPro camera. And the end at the GoPro camera, I want to be around 20. And right now, the range from 20 to 22 is pretty level and even at the GoPro. And because the higher numbers are not a straight-on look with the GoPro, I will let you know exactly what number we are starting our titration at. It is at exactly 5 mils. The meniscus is at exactly 5 mils. Let's check our temperature. And we are now at 50.6 degrees, so we don't have that much more time to wait. Once we hit 70, I'm going to turn the hot plate off, let the radiant heat keep it heating up and going. But I am going to keep the stir plate going, so that way we can make sure that it stays nice and thoroughly mixed as we're going. We're at 8. That's 74, 75. All right, I'm going to shut it off. Show you guys we're at 75.3. So now it's time to start the titration. We want it to be around 20 mils in, so we think it's going to be around 20 mils in. I'm going to lower this just a little bit. And here we go. Notice we are draining it pretty steadily inside of there because that final endpoint is going to be that purplish color, but it's eating it up as fast as the purple is dropping in. So actually the final endpoint is going to be a pinkish color. We're at about 23 mils added. We should be getting darn close. So I'm going to slow it down a little bit. Slow this down to adding dropwise. I'm noticing in the video it's starting to take a little bit longer for that drop to get eaten up. Let's take a look at this. It's a nice pink color, very faintly pink. I think we are there. I think we hit our endpoint. So what I'm going to do is get that last little drop down, and then I'll raise this up so that maybe you can see our final volume is exactly at 39.0. So the first one was 5.0, the final one is 39.0. Okay, guys, with that information, what is the molarity of the KMnO4 standard? You've got the mass of the oxalate, you've got your balanced equation, you have the amount of potassium permanganate used. What is the molarity of our standard? Bring that to class.